Thank you very much for the nice introduction, Professor Seminara, and thank you very much to the committee for inviting me. It's such an honor being a young researcher to be hosted and have the opportunity to share my research experience in this important venue. So I am a marine ecologist by education, and I will start from the word of the previous esteemed speaker, telling you basically what is the state of the art of the research into the marine plastic pollution and what happened to the plastic once it escapes the waste management loop and it ends up into the marine environment. So I hope that with this brief talk I will be able to give you just an overview of what is the state of the art and what are the most pressing questions that the scientific community working on these topics is trying to address these days. So, but to tell you this, I have to start from how I got involved in this field of research. Originally, I was not working on plastic. Back in 2013, I was working on marine invertebrates. And for a large European project, I was basically studying how these tiny marine invertebrates will move around the marine environment with currents and how the marine protected areas were connected to each other through marine currents. So I was supposed to study this tiny colored organism, and I went at sea with our research vessels collecting samples. And we were collecting samples with this kind of net you see in this picture here. This is an Houston net, and it collects the first 40 centimeters of the surface water of the ocean. And this is what the plankton samples would look like. So normally in a clean ocean, you will have to find this mass of gelatinous plankton. These are tiny microscopic organisms which are the basis of our food chain. But it appeared immediately clear to my eyes when I started collecting samples in the Mediterranean Sea that the situation was drastically different. So, and I show you here just a few examples of the samples we retrieved from the surface of the Mediterranean Sea, and this was back in 2013. And here you see many other examples of samples, and the more samples we will collect, the situation was always the same. Literally a soup of thousands and thousands of tiny plastic fragments, which are the so-called microplastics. And I also want to emphasize this picture here, which I find particularly hilarious, that I don't know if you can read here, but there is written "Enjoy packaging" on this tiny piece of plastic we collected. This was in front of the Gulf of Naples in 2014. Then we kept collecting samples. This map shows you the distribution of all the samples we collected during those campaigns in 2013 and 2014. And then we went back to the laboratory. In the laboratory, we analyzed and extracted all these tiny plastic particles from our samples. I was really surprised to find out that there were more of these tiny plastic fragments than the larvae and propagules that I was supposed to study for that European project. And so the idea came at the time to publish this observation. It was just an empirical observation. So we did our best to standardize all the process and to extract all these particles, to analyze the chemical composition with infrared spectroscopy. In the end, we analyzed more than 14,000 particles. And these are the results. The results are basically quite striking because we found concentration of microplastics up to 10 kilograms of microplastics per square kilometers in the Mediterranean Sea. This was again in 2013. And these microplastics were composed of 16 different polymers, although the vast majority of them was polyolefin, so polyethylene and polypropylene. Basically 60–70% of them were polyolefin. And overall, we estimated that on the surface of the entire Mediterranean Sea, there will be between 1,000 and 2,600 tons of microplastics, so tiny plastic fragments smaller than 5 millimeters. And then also, besides these microplastics, there are also a fair amount of larger plastics on the surface of the ocean. These larger plastics are the so-called macroplastics. So we also did some systematic observations of floating macroplastics in the surface of the Mediterranean Sea. And you see the results here on this map. And we estimated that in 2013, we published this result. In 2013, there would be more or less 62 million floating macroplastics over the surface of the entire Mediterranean Sea. And then these studies were happening in 2013, and you see this dashed line here shows you the number of scientific papers published about microplastics in the literature. At the time were very, very few. But since then, the topic has literally exploded. The interest of the general public and of the scientific community has really surged. And you see, this is the surge in publication that we experienced in this last year. So I was in the middle of a cyclone that was just about to explode. But to be honest, the first evidences for the scientific community started to appear much earlier. The first scientific papers about the occurrence of plastic in the marine environment were already published in the 1960s, where the ingestion of plastic by albatrosses was already reported, while in the early 70s, several papers published in Science showed the presence of the abundant presence of these tiny polystyrene spherules in coastal water. This was published in 1972, and this table is extracted from that original paper. So the issue was known to the scientific community, but it was not until 2004 when Richard Thompson from the University of Plymouth published this brevia in Science that basically the real interest of the scientific community spurred. And this paper was one of the classical seminal paper that basically gave the start to a huge and very active field of research. And the paper was called Lost at Sea, Where is All the Plastic? And then it took the scientific community another 10 years after this paper to do some synthetic studies. So some researchers, some colleagues, they collected all the data available in the scientific literature, pulled them all together and tried to understand what is the status of our global ocean regarding microplastic pollution. And Andres Cosar in 2013 in PNAS, and then Marcus Ericsson in 2015, they published this global synthesis showing that the total amount of microplastics floating in the surface of the oceans in the entire planet was about 250,000 tons of plastic, and this was 2015. Similar results were then published by Eric van Sebille in 2015, and interestingly, the global estimate was similar in magnitude to the two previous one I just showed you, but it also highlighted how the Mediterranean Sea was one of the main global accumulation zones for plastic pollutions. And the quantities of plastics in the Mediterranean Sea were also even higher than what is usually found in the famous floating island of trash in the main Pacific gyres. But what is really interesting about this is that if we do some budgeting exercise about the amount of plastic entering the ocean, this was nicely showed also by the previous speaker. Basically, we have a global production of plastic materials. Then we can, by using worldwide data on solid waste production and coastal population density, we can estimate how much of this, what is the share of this plastic that will enter in the marine environment every year. And this was estimated by Jana Jambek in Science in 2015 to be about 8 million tons of plastic a year. So the global input, the annual input will be of this order of magnitude. But interestingly, the total amount of plastic that we find at the surface of the ocean, floating at the surface of the ocean, is only 1% of these 8 million tons. And so I show you again this paper from Richard Thompson in 2004, because we have a problem here, because we do not know where all the plastic entering the marine environment is ending up. And so the question was more actual than ever: where is all the plastic? And this basically is the question behind most of the research that I do and many other colleagues do, trying to understand what happened to the plastic when it enters the marine environment and where is all the plastic. And this is like the famous elephant in the room, because we cannot really ignore this paper that was published in last year in Nature by Elakam et al. And they basically showed that the global human man-made mass exceeds all the living biomass. And specifically, if we look only at the plastic man-made mass, this is the double, exactly the double of all terrestrial and marine animals combined. So we really have an elephant in the room, but we really don't know where is it. So we're trying to understand what's happening to this plastic. But as you see, there are a lot of question marks yet. We need to fill this question mark, and our research tries to fill this question mark. So how much of the plastic that enters the ocean every year is in all these compartments? And one of the hypotheses that was put forward was the seafloor. Of course, when it was hypothesized that most of the plastic will sink once it entered the marine environment, and the deep sea was hypothesized to be a major sink for these plastics. And indeed, wherever we go, observing the ocean seafloor, we find considerable amounts of single-use plastic and mainly packaging materials. And even the deepest point of Earth, the Mariana Trench at almost 11 kilometers below the seafloor, was found to host some plastic fragments. And recently was also demonstrated that behind the North Pacific garbage patch, the infamous floating islands of garbage, there is a certain fallout of plastic. So this plastic, after a certain time in the marine environment, it will start sinking in the water column. Another option that was put forward was that a large share of the global budget of plastic was sitting on the coastline. So, and indeed, this was recently demonstrated by a paper published in Scientific Reports, where this author basically showed that probably most of the plastic mass entered the marine environment since the 1950s is not disappeared from the ocean surface, but is probably trapped in a cycle of beaching and resuspension in the marine environment. So they will be sitting on the beach until the next storm will resuspend them in the marine environment and then beaching again. And indeed, the situation on many beaches around the world is similar to the one you see in these pictures here. Another option could be fragmentations. We really, here we know still relatively few. Those anecdotal figures about plastic persistence in the marine environment, most of the times they are not based on solid scientific data. What we know is that plastic is not an inert material. Plastic, once in the marine environment, under the action of UV rays and wave actions and so forth, it will start fragmenting and degrading into smaller and smaller particles until it will enter the nano world. It will, as you see in this graph here, which was published in 2017, most of the plastic fragments are actually below 10 micrometer in size. And we should expect that below these 10 micrometers, the number of particles should be higher and higher. So we enter into the nanoplastic world, and we really know nothing about this, or we just have a few evidences about this. We know that plastic, though, is degrading into these nanofragments, and we urgently need some experiment, and we are starting to do some experiment also with Hydra Marine Science. You will hear from Miriam later on more insights about these degradation experiments in the marine environment. We really need to understand more about the degradation of plastic in the natural environment. And also, the oceans are not empty. The oceans are home to millions and millions of marine organisms, and all of them are probably now, by now, interacting with plastics. And one of the last report in 2018 estimated that over 1,400 marine species are now interacting somehow with plastic fragments, either ingesting them or being trapped and entangled in these plastic items. From the smallest plankton items that you can see in laboratory condition can ingest tiny plastic particles to larger organisms like seabirds or marine turtles. Or it was also hypothesized that while the plastic moves around with marine currents, it can be transported to the poles, to the most remote corners of our planet. And indeed, scientific evidence is just showing that this is happening. It was hypothesized, for instance, that the Gulf Stream, the thermal circulation, will probably transport every year important amount of plastics into the Arctic oceans, as is nicely shown in this graph here in the top right. And plastic is being found actually in polar regions. But I show you once again these figures from Andres Cosar in 2014, just to emphasize that at that time there were no data in the Southern Ocean. You see all these question marks. We really knew nothing in 2014 about the occurrence of these plastics in Antarctica, in the Southern Ocean. And so,
Pronto, Alberto.
and so this is the reason why This is the reason
Abbastanza
why.
bene, ma sto in questo momento.
So this,
Ecco.
sorry about this. So, and this is the reason why between 2016 and 2017, I had the privilege of embarking in an historical expedition around the Antarctic continent. And I had the chance of circumnavigating Antarctica for 5 months, visiting some of the most remote islands of the planet. And we were specifically looking for the arrival of plastic in the Southern Ocean in one of the most remote corners of our planet. And no surprise that we found plastic even there. This is a plastic fragment we found in the middle of a penguin colony in Marion Island in a South African island in the Southern Ocean. We published this result recently, and we showed that although plastic is present in Antarctica, it's present still, fortunately, at very low quantities. So the Southern Ocean and the Antarctic Ocean can be probably considered as one of the cleanest part of the planet so far. So plastic is there, but as you can see, the concentration of plastic are much lower than the concentration we find at higher latitudes. But this is basically how we entered in the so-called plastic age. We cannot longer ignore the abundant presence of plastic and the widespread, diffuse presence of plastic in our environment. And plastic is now so abundant that it has been proposed in 2016 by these colleagues that it will be used by future generations as a stratigraphic indicator of the Anthropocene. So exactly as we were using other material as indicators of previous civilization, our civilization will be most likely identified by a geological record of plastic into the environment. And as usual, when you start digging into a problem and you start doing research, the problems actually multiplicate and the open question will actually increase in number. And as Snoopy says here, I apologize, he's in Italian, but he says nothing creates, nothing is destroyed, everything gets messy. And the open questions are multiplying. The more research we do and the more open question we have. And so we really know to answer some of these. So where is microplastic accumulating? What factors can influence their behavior and their toxicity for the environment? Will there be some long-term effects for the marine environment related to the abundance presence of these items? And what are the human health consequences and how can we solve this problem? And more recently, it was demonstrated by this paper in Science that plastic is raining all over the world. And on average, on the protected areas of the United States, there are some atmospheric deposition rates of microplastics of about 132 microplastics per square meter every day. And maybe vice versa. It has been demonstrated also that during storms, the microplastics which are present in the marine surface waters can be resuspended in the atmosphere, in the sea spray, in the sea aerosol. And so plastics are really now flying around, and we are starting to do some experiments to understand how important is this process and how much of the plastic that is entering the ocean is actually arriving through the atmosphere. And also we want to understand better what are the vertical and horizontal fluxes of this plastic once it arrives in the marine environment. We need to know where it goes, how long it takes to arrive there, how long it stays in the surface, and how long it takes to sink. And so we are starting some experiments also to study this process in the marine environment. And then we can use some other more sophisticated tools to study. For instance, we're using numerical models. We can track the floating plastic we see. For instance, this paper we published in the Adriatic Sea, we can track where the plastic was coming from and where the plastic was going and how long it will take to move from one place to another. And this information can be useful to understand where these plastics are likely to create more negative impact for the marine ecosystems. And also another frontiers of research is the litter detection from space. So we can use satellites to track this plastic at the ocean surface on global scales and understand what are the global accumulation areas and what are the most effective intervention areas for instance, for cleaning operations. And then there is, I just want to briefly mention you this other side topic, which is textile microfibers. This is a study we published in Science Advances last year, And it's about a global survey of the widespread presence of textile fibers in the marine ecosystem. So it's a nice story of collaboration between researchers, because at that time, while we were circumnavigating Antarctica, we were using much larger mesh that would basically 2 cores to sample these tiny textile fibers. But another research team, which was on board the ship with us, they were in charge of studying phytoplankton, so much smaller microalgae. And they kept noticing in their sample these tiny colored fibers you see in these pictures here. So they brought this issue to our attention, and we decided to start paying attention to this and start collecting samples specifically targeted to the textile fibers. We collected samples all over the world, as you can see from this map here, and we tried to understand how important is this emerging pollution for the marine ecosystem. But to our surprise, these textile fibers are really abundant. You see some examples here of the filters. We were just filtering seawater on these filters, and this is the situation. Hundreds and hundreds of textile fibers are present also in the most remote corners of our planet right now. But when we analyzed all these tiny fibers, we have the biggest surprise because we were really not expecting this. We know that currently, synthetic fibers account for 62% of global textile production. So polyester and other synthetic polymers, they now represent the vast majority of all the textile industry. But most of our samples, actually, most of the fibers we analyzed were actually made of cellulosic and natural materials. So we're actually cotton and wool fibers. And for some reason, these fibers are not degrading in the environment as we would expect. Probably there is still some research to do on this, but probably the role of dyes and additives and chemical additives which are used during the textile production, they probably have a role in this. But what we can say for sure is that natural and synthetic fibers are really abundant now in the environment, in marine water and in marine organisms. So I'm almost done with my presentation, and I thank you very much for your patience. I just want to say a few words about potential solutions and mitigation. So we will surely hear more from the next speakers about these very important issues. I just want to give my 2 cents. This paper was published recently in Environmental Science and Technology, and it basically shows that sometimes the legislation has been a bit too fast. We need to do some proper research before replacing products on the market and before doing some drastic legislations. And for instance, this is one of the famous oxo-degradable plastic bags that were introduced into the market recently. Well, after 3 years in the marine environment, this bag showed no sign of degradation. And this is a study made by my colleague Imogen Napper. And what I really like also to emphasize here is the flooded bathroom theory. Basically, from my point of view, we hear a lot talking about cleaning up operations, but it won't make much sense to start, if you have a flooded bathroom, it doesn't make much sense to start cleaning up the floor of your bathroom if you don't close the sink before. So if we want to really solve the problem, we need to close the tap, and then we can start cleaning the floor. And we know this important symposium is about plastic and circular economy. We know that this is the solution. We need to shift from a linear economy to a circular economy. And in order to do this, we can stress the importance of the consumer for the famous fiber principle. So we can all change our behavior and reuse, reduce, repair, recycle, refuse, and let me say also research. But as important as the consumer and the waste management is probably the polluter principle and the extended producer responsibility. So these concepts are probably key in implementing at the global scale some circular economy programs, but I'm sure we will hear more in the coming days about this. And this is my last slide, and it's a bit of an ugly slide, but I really like it because I think we all need some optimism. Ocean is the so-called ocean optimism. right now. The ocean is facing major issues, of which plastic is probably not the most important one. We have overfishing and climate change, which are much more pressing than plastic pollution. But we cannot ignore the widespread presence of these materials in the marine environment. What is comforting is this paper, which was published in 2015, that basically shows you that for many other emerging contaminants, that was an onset of emergence, which is identified by these yellow squares here. After a few years, there is a peak into the scientific publishing activity, which is shown by these red squares here, and which is often closely followed by some regulatory actions. So these researchers, they try to extract this data for all these pollutants here, including DDT and many other famous pollutants. And you see microplastics here in the last row. They identified the onset of emergence for microplastics in 2008. And then it will take some time to the scientific community to reach a peak into in the publishing activity, which was forecasted by this researcher around 2022, plus or minus 4 years. So we might as well be in the middle of the peak in publishing activity. And then we all hope that in a few years, there will be some strong regulatory actions, probably doing some good for the oceans. So I am done, and you can find here my email address if you want to know more, and I'm here to answer your question if you want. Thank you very much again for the invitation.